Alright everyone, I am back for episode 2 of building a lovely, awesome computer that will be able to play some games. Now you may be seeing some lag on my side, and that is because in my other window I am processing episode 1, literally 30 seconds after I recorded it. So, that might affect you guys. Actually, it's going kind of fast. I'm on file 2 of 9 already. So basically what I was going to do in this episode is develop a basically a logic unit that can add and subtract, okay? I can't say that in its full form. Basically, we are going to want a few inputs and outputs. So let me get rid of this crap. Alright, we're gonna want, I believe, 2 inputs, maybe? Yes, we're going to, but hold on, we're gonna need 2 inputs for 1 bit. We're gonna have a bottom input, which is set 1, and then we'll have set 2 up here. So 1, 2, 3, 4, 5, 6, 7, 8. And I believe if I can click this guy, get that. This guy's really helpful for separating some wires when you don't want them connecting. Although I could just use different colors, but I don't feel like putting them all in my inventory right now. Ooh, things are loading good on my other screen. So basically, I'm going to have... This is going to be one... what's the word? 1 bit? 1 bit, I think. And then that whole row is a... Wait a second. Is that how it works? Yeah, this whole row will be able to process like 1 number here and then a number there. So I guess you could say 1 adding or subtracting operation. So 1 operation per cycle. So for example, a cycle is 2 seconds. The numbers will load in the different values here. It'll go through the processes of adding or subtracting, and then it'll come out in a single output right here. Probably actually gonna need maybe more space, I don't know. But this will basically be able to add and subtract 1 number at a time. And this is a single digit number, which is considered 1 bit, I think. 1 bit. No, it's a byte. No. Well, for logic units, I guess it's a bit, because they call it, like, 32 or 64-bit computer. So I guess this is a bit. And 1 bit, looking at this now, it looks kind of big, but I do have all that area, so I guess it's not that bad. I could probably compact it down some way. I could have, like some inputs here, like that. So, like, that could be the inputs. They'd be the central processing unit for the adding, subtracting, and then we could have the outputs there. And it's a little bit smaller, as you guys can tell. Oh gosh, breaking things already. What did I break? I'm getting stuff in my inventory. So what I'm going to have is in 1 row of these, I'm going to have a computer Sorry, I got something stuck in my throat. Give me a second. Alright. So let me just take this over here. We are going to have an input here. And an input here. So number 1, number 2. And I guess we have to do it like that then. And basically we're going to have a computer like that. And I actually need that piece of wire back. Give me that wire. Why did that happen? Where did it go? So it'll be like that. And I could actually compact that a little bit more, I think. And then it's going to give me 2 inputs, so I'm obviously going to need 2 outputs. And you guys may be thinking like, whoa, well 1 and 0 obviously makes 1, so just output 1. But what if you have a 1 and a 1? Then that technically makes a 1 and a 0. Like, okay, 1 plus 1 equals 1, 0 in binary, of course. So how would we get that to carry over to the next bit in the row? Well, we have the basic output here, but we're going to need a carry. And basically what a carry is if you have that situation where you have a 1 and a 0, it'll add on to the next computer, and basically on the next computer it would come in here and it would go with this. So if this was 0 and a 0, nothing would be output, but if there's a carry of 1, it would output that. If that's 1 and this is 1 and that's 0, that should output as a 10 in binary. So you would obviously carry that over also. And if this one, and the carry in was on, I think you would, I'm not sure about this. I think you would have that output and that output on. I'm not sure though, so don't reference me on that. I have no idea. I'm not extremely smart in this area, so I'm going to try to make a working one now. So we'll have input 1 and input 2. And I want the computer to face me. We'll have the computer there. We'll have that works, and we'll have there. Then we'll have a carry in, a carry out, and an output. So we got that. Alright, so hopefully this should work. Alright, it should. We actually don't need that there, because that's an output. Outputs don't need a lever, obviously, for various reasons. So I'll do edit, add. And let's just save it so we get add. So I'll do, let's see. Let's do print adding mode ACTIVATD keyboard ATED, please. Adding mode activated. It shouldn't really matter because I won't be going into this computer and I won't need any outputs except for redstone. Okay. So what we need to do is check for inputs on here and here. So we're going to do bit 1 equals rs.get input on the top, bottom. I don't know if that's supposed to be capitalized or not. Actually, I don't think it is. Equals redstone, got input on the bottom. And then bit 2 is equal to rs dot, guess what? Pretty much the same thing. If I can type. Except on the top. And then we'll do carry in is the redstone dot get inputs on the right. Alright guys, I will be back in 1 minute. Alright everyone, I am back. Sorry, I had some things to take care of. Alright, back to where we were. So we're getting the bit 1 and bit 2. And then we're going to get the carry in right here. And basically we want to output our data. So how we do that? How are we going to do that actually? So basically it just gets inputs. Actually, I want to put this in a loop. So while true, do this junk. I'm just going to indent this because I'm OCD like that. And then I'll end it. So it'll constantly check for inputs and give outputs. I'm going to add a sleep for 2 ticks to make sure it does not tax my computer. So by tax, I mean kill. So I want to say if bit 1 equals true, then I will do, let's see, set, is that a dot? I can't see. Alright, dot set, output, what is it, the back, and I need another variable, true. So if bit 1 is true, so if we're getting input from the bottom, 1 bit, it'll process it, it'll set the back to true. So if that one's on, this one's on. 1, 1. 1 in, 1 out. So we need to turn it off if it isn't. So else, hopefully I know how to do this. rs dot set output on the back false. Why is FALSE? Why is that not highlighted? Is it supposed to be highlighted? False. Oh, I spelled it wrong. FALSE. LSE. False. Alright. We're getting somewhere. So let's test this out. Let's see. Add. It's adding mode activated. If I flip that one, it shouldn't do anything because I haven't programmed it yet. But if I flip this one, bam! Instantly turns this on. Almost instantly. It adds it up, and while it remains true, that should stay on. So if I flip it off, it should turn off. And it's about maybe 2 ticks delay. It's decent right now. It doesn't need to be that fast of an adding subtracting because I don't think we'll be doing too much of that. Of course, that is the main kind of stuff for a computer. It shouldn't matter too much. So we wanna edit the add. So Control T to terminate a loop if it doesn't have a endpoint by its own. And we want to do if bit 1 is equal to true, and bit 2 is not equal to true. Alright, and bit 2 is equal to false. So if that one's true, that was false, then blah 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 blah. And then I'll do if bit 2 is true and bit 1 is false. End it. So I'll do the redstone dot set output back false for if it's false. It's not indented. Why is it not indented? Alright, and then I'll do redstone dot set output back true. And I'm sorry if my keyboard's kind of loud. It's not the best keyboard. I'm planning on getting a new one sometime soon. Oh man, I'm burping a lot. Okay, let's see this. Okay, no errors. So basically, if that one's on, it should output. If that one's on, it should output. What happens if they're both on? Alright, it doesn't output that. Maybe I came in error. No? Really? What's up with that? Alright. While true. If bit 1 if bit 1 is true, so if the bottom one is on and the top one is off, then it outputs the back. Otherwise, set output back false. Oh, I see what it's doing. It's not even going to care that. It's always going to have it false if this isn't true. And if this is true, it can't put this true because this is false. Ah, there we go. That's a problem. So I could probably just move this if into this else. Maybe I'll try it. So we don't need that. Else. Let's have another if. So do else. Indent all this crap. Okay, let's see. If that has an else. I don't think we're going to need this either. So I'll just put that in the back if nothing else is good. Actually no, that's not going to work. Ugh. How am I going to do this? Okay, hold on. Let me just not even save this. So basically, let me think about this for a second. I am stumped. If bit 1 is true and bit 2 is false. Okay, see if it's maybe it should how do I want this? Maybe I should have it all in true false statements. Yeah, I think I'm going to do that because I don't like this. This is way too much crap. So I'm going to do I'm going to make a comment And I'm going to say testers. End of testers. And inside testers, I'm going to do is bit 1 on no. What should I do? I gotta take off this jacket because I'm sweating. 1 second. Just take this off. Oh gosh, it's hard to get off. Ouch, static electricity. Okay. Ow. Oh, I pulled a muscle. Okay. Let's see. In here, I am going to put... Alright. Let's just think of a stupid name. Okay. If bit 1, I guess. It'll equal to rs.get input. No, because I already have things declaring if they're on or off. Wait. If I can't remember what I was going to do there. If it tests. Alright, so it tests oh gosh. So false, true. Guys, I will be back when I figure this out. I don't want to make you guys wait through all my crap I'm mumbling and stuff. So I'll be back in a minute. See you guys in a minute, or 10. Alright everyone. I am deciding to hold off on this today. I'll probably continue this tomorrow. I got a lot of thinking to do and I have a headache already. So I'm going to take a break till tomorrow. I'll work on it a little bit tomorrow. Maybe I'll get an episode out then. Yeah, I guess I'll have to. I just can't put off this project. It's a really nice project and stuff. I'm just so excited to do this. I want a computer in Minecraft to play Minecraft on. Ooh, that'd be interesting. I just got an idea. What if I took a turtle and I got a few different colors of wool and I put it in here and I wrote a program to wirelessly make the turtle place the different colored wool for a multicolor screen. Might be a good idea. Oh well. I guess I'll see you guys hopefully tomorrow, maybe 2 days. I have no idea. See you then. Take it easy, guys.